Good morning and welcome to today's CMG webinar. If you are not familiar with our organization, the Computer Measurement Group is a not-for-profit worldwide organization of IT professionals committed to digital transformation initiatives and best practices, including the measurement and management of computer systems and networks from a performance and capacity perspective to drive ongoing change. We offer in-person and online events like this one, which you can find on our events calendar at cmg.org/calendar. Join us for the next conference in our virtual event series. The next event is all about scalability and reliability. The exchange will explore how IT infrastructure is evolving to keep pace with digital transformation, new technologies, and processes such as IoT, AI, and the necessity of keeping up with customer demands. The exchange will host a series of speakers to discuss mainframe, cloud, and hybrid infrastructures, edge computing, security and governance, and IT finance and planning. You'll receive a follow-up email to this webinar that includes a link from HelpSystems to register for the event at no cost. So I want to thank you again for joining us today for How to Keep Cloud Costs Down, presented by HelpSystems. And I will turn you over to Per Bauer. But before we get started, I want to make sure that you know that you can submit questions through the GoToWebinar panel. We will be collecting those questions throughout today's session and have a Q&A at the end of the presentation. And I'll turn you over to Per.
Okay, thank you very much for that. So I hope you can see my screen now. I'll turn over to presentation mode. Okay, so welcome to today's webinar. So we'll discuss the cost aspect of cloud and how to optimize and manage the cost of cloud from a capacity perspective. My name is Per Bauer. I'm with HelpSystems. I'm a Director of Solution Services, which means that I'm involved in most of our engagement with new clients and existing customers. I'm managing a group of capacity management experts that are doing pre-sale and post-sales activities around our solutions. So today's webinar is going to be about these 5 aspects really of cloud computing. So first we'll go through some basic concepts and terminology in the cloud space so we're all on the same page briefly. And then I'll have a short discussion about how it changes capacity management, how it's impacted and what needs to be done different and what remains the same. And then we'll talk about the 2 big items around cost optimization. So first, how to get to the cloud, so how to do the best migration over to cloud. And then once you're there, how you control and minimize ongoing cost once you're in the cloud. And then at the end, we'll wrap up with a summary, and we'll also try to address any questions that you've submitted through the chat window. So if there's any questions based on what I'm talking about or what I'm not talking about in my presentation, you can submit them via the chat, and hopefully we'll have time to deal with them at the end. If not, we'll do a one-on-one follow-up, of course, and address any questions that you have. So concepts and terminology. So what are we talking about when we talk about cloud? I've used this slide a couple of times before, so it may be familiar to some of you, but basically it's about, we have traditional IT, we have private cloud, and we have public cloud. Both the private cloud is different from public cloud in the sense that it's run either on-prem or in a co-location, but it's something we own and control. So it's our own cloud that we host. Cloud come in multiple different forms, or it's delivered in different forms. It could be infrastructure as a service, platform as a service, or software as a service. We're going to mainly deal with the infrastructure as a service piece here because that's really where you need to do most of the capacity and performance management, and that's really where we are as capacity managers or performance managers are mostly involved. Hybrid cloud is the term where you use a bit of both. So you use public cloud in combination with private cloud, not necessarily mixing the two in the same service, but at least you're hosting both of them, and you need to be in control of both of them. Multi-cloud is another term that is used for when you have multiple vendors for your public cloud offering. Mostly we see that around platform and software as a service, where it's quite normal, or it's sort of the default is to choose multiple different vendors, the best of breed solutions in terms of SaaS solutions, for example. When it comes to infrastructure as a service, we don't see as much multi-cloud because the differences between different cloud providers, etc., makes it a bit more difficult. There's really large organizations probably have a mixed bag of infrastructure as a service providers as well to spread the risk, but normal cases, multi-cloud is mostly about platform and software as a service. And then the overall everything in this picture and anything else probably is hybrid IT. So hybrid IT is the term that we use when we include also the traditional IT. So most of our services in the future, or now and also in the future, will run in hybrid IT, meaning that we have a portion of it, or we have dependency to our traditional on-prem IT, we have stuff in the public cloud, and we have stuff in the private cloud, and all those things need to manage in together in order to make sure that we can provide the services that our customers are looking for. So this is sort of concepts and terminology. If we look at the reasons for moving over to infrastructure as a service or public cloud, the first one that comes up is cost reduction, or probably more cost commitment. So avoiding the CapEx expenditure and then the depreciation over 3 or 5 years for that CapEx, rather having an OpEx approach where you don't commit to any cost. So the day that you turn off the service or you sunset a service, you can turn off the subscription and there's no more cost incurred. So managing cost that correlates closer to how your services are actually provided. That's a big reason for using cloud. Another one is improved agility. So arguably or unarguably, it's faster to provision resources in a public cloud than it is to get them stood up in your own data center. So for those reasons, cloud provides characteristics that is very, very attractive from an agility perspective. Alignment of strategic focus, so focusing on your core business, not having an army of people doing operations, managing your data center, carrying and feeding physical infrastructure, but rather giving that away to someone else and focusing on what makes you special. Operational assurance, for smaller organizations who can't afford or can't manage to keep all the expertise in-house, it's sometimes safer, or it feels better to rely on a big cloud provider to give you assurance around security and operational excellence, etc. So it's basically giving the job to the experts rather than trying to do it yourself. And then the last one is scalability, which at least in theory, the cloud has infinite resources, and you can scale up and you can scale down much quicker than you could in on-prem environments. So these are sort of the reasons for why organizations are moving over to the cloud. If we look at some of the challenges in the cloud, this graph chart comes from a report called State of the Cloud, which is from Flexera. It was originally created by a company called RightScale, who's now acquired by Flexera. So they put this report out every year where they do a big survey with a lot of people involved in managing cloud workloads and cloud applications, cloud hosted software, and ask them a bunch of questions around how they do things and how they see things. So the biggest challenges in the enterprise segments is managing the cloud, managing the cost or the spend around cloud. Second to that is the governance aspect of it, which is also kind of ties into what we do as capacity managers. So governing the whole operation of the cloud infrastructure that you're using. And there's also a set of other ones that are of big interest, but it's interesting to see that cloud spend is really a big one in this. If you look at this from another aspect or in a different light, so you categorize the respondents in terms of maturity. So you have beginners, you have intermediate users, and you have advanced users. Governance is still the top concern among those, or the top challenge, but managing cloud spend actually gets more important the more mature the organization gets. So the more you get into using public cloud, the more you realize that you need to manage the cloud spend in a effective way. The lack of resources and expertise is more important than the beginner level, which is to be expected, I guess, because if you're a beginner, you obviously haven't been able to build that level of expertise yet. So it's kind of to be expected. But it's interesting to see that the cloud spend aspect becomes even more important as the more you get into using cloud. Some other general observations. All these comes from this State of the Cloud report. So the amount of wasted resources in cloud is high, but it's still underestimated. According to the report, it's 27% on an average that is being wasted in cloud environments. So that is not, justified or can't be justified or used. I've seen other numbers. Many of them are actually higher. I've seen in the range of 30 to 40%. So there's a lot of waste going on in the cloud, and obviously that has an impact on the cost of running it. So given that high number, a surprisingly small portion of organizations are actually addressing this systematically. So things like identification and shutdown of dormant instances and right sizing, etc. It's not happening at the level that you would expect, considering the amount of waste going on. Another thing that is also appears in this report is that the use of reserved instances, which is a big way of saving costs in the cloud, is not fully exploited either. So it's one thing how much you actually decide to use it based on some sort of investigation or analysis, but it's only a minority of organization, 47% in AWS and 23% in Azure, that is actually using it at all. So the rest of them haven't even considered using reserved instances. We'll come back to reserved instances, but it's a great way of potentially saving money. So there's a relatively high level of immaturity, I would argue, when it comes to actually looking after cost and keeping control of cost in the cloud. So that sort of sets the scene. So this is what we need to address as capacity manager, and what we need to work with. So what becomes of capacity management in the cloud? So capacity management had always been this balance between risk and efficiency. So try to sort of, in terms of risk, plan to maintain performance and availability of a service under changing circumstances. So modeling different types of scenarios and see what happens to the infrastructure that is underpinning those services, and making sure that we have a predictable operation for our main services. The other aspect of it is the efficiency. So ensure that the right amount of resources are being used, so we're not over provisioning or not wasting resources, but at the same time not using or being too cheap and are using too little resources. So keeping that balance has always sort of been, that's a classical pitch for capacity management. In the cloud, this changes somewhat. From the risk aspect, we've said this, or we touched on this before. So capacity is infinite in the cloud, at least in theory. So it's not about making sure that your growth or your forecasted scenarios fit in your current set of infrastructure, but you can actually get more infrastructure. So, but still, in order to make use of that infinite capacity, you need to have an architecture and a design of your application that supports that. So more focus is put on the architecture and its the limitations of the architectures you're using, and it's also about trying to identify if there's any explicit or implicit limitations of the service provider, because even though cloud is supposed to be this infinite set of resources, it's still servers running in a data center. And no matter how good a job your service provider or the public cloud provider does, there may be occasions or instances where you hit a brick wall and you can't expand, or you can expand, but that expansion causes you to move across multiple physical locations, which causes latency to your application, etc., or incurs a different type of cost that you're used to, etc., etc. So identifying and understanding what are the limitations of your service provider is also a big part of managing the risk in the cloud. From an efficiency perspective, it's also different. So there's no sunk cost. So as we said before, there's no CapEx involved. So it's not like if you've made a mistake in the past, you can sort of, it's hard to recoup that, and you don't have to care. You can basically use the infrastructure that you've already provisioned. Any type of optimization that you do in the public cloud will pay off immediately, because you shut off resources, you pay less, and it shows up on your next bill from the provider. So you need to have an increased focus on that OPEX, and to have a predictability around that, so you know what the bill is going to look like in the coming month or in the coming quarter. But also the way that public cloud and the cloud-based workloads are designed and being operated and developed, you lose some of the control over the provisioning of resources. So where we used to put a lot of effort into right-sizing things up front, you now have to do more ongoing right-sizing with retrospective or a historical perspective. So you reclaim resources, or you turn off resources that aren't being used. So the shift moves from proactive to reactive to a certain extent. So what does this mean? So optimizing the capacity of a public cloud is really about three different things. So you need to optimize the migration over to the cloud. You need to analyze and right size and clean up activities that should be ever ongoing. And then you need to build some sort of consumption models to predict cost for your services, because otherwise you will not get this predictability that we talked about. Some best practices around this. So when it comes to the migration, a pure lift and shift approach we see a lot of that in the market, and we see, among our customers and among the companies we engage with, we see a lot of lift and shift happening, but it should actually be the very last resort. At least you should put some more effort into it than just, simply moving an application across to the public cloud. We'll come back to that later. You need to continuously look for opportunities to right size. So you have to have this ruthless drive for efficiency. You need to always look at dormant resources or archaic storage resources that aren't being used anymore, etc., and turn those off. You need to track and allocate the fully burdened cost across your different entities, if those are different regions or geographies or lines of businesses or even internal customers or whatever. You need to push out the cost and make the different tenants pay for what they're actually using, because that's the only way to drive efficiency long term. And then you need to define some sort of capacity models for your main consumers. So the biggest services, workloads, etc., applications that you run in the cloud, you need to have a capacity model where you understand how business activity correlates to resource activity, and by that, getting business forecasts and try to translate that over to resource consumption, and by that get some sort of predictability. Easier said than done, but those are sort of the things that you need to do in order to optimize your existence in public cloud. When it comes to private cloud, we haven't talked too much about private cloud this far because we're not seeing as much traction around that, but it's a similar setup, basically. But when you manage it or when you optimize it, you need to think about it slightly different. For the private cloud, you have the cloud service as such, which is the layer on top of your physical infrastructure, where you easily provision and hand out resources to your different tenants. You need to optimize those predefined configurations that you have. So you need to have them in certain sizes, and those sizes needs to be well calibrated so that they sort of fit the need of your organization. And then, as you do in public cloud, you also need to discover and reclaim dormant and archaic allocations in that private cloud, and repurpose those or reclaim them and use them for something else. But you also need to manage your infrastructure, because you're in control of the infrastructure. So you need to make sure that you sweat your assets, so you use your infrastructure at a decent level, or at the right level, not too much and not too little, of course. And then you need to predict and source for future demand, because there's probably some lead times involved in sourcing new infrastructure for this. And since the cloud service is expected to run smoothly, you have to have a forecasting mechanism where you can see those things well in advance, and to incorporate your internal lead times, etc., to put things on the floor to provide the infrastructure for that private cloud service. So some best practices around that. The first one is you need to fund and budget the private cloud as a standalone initiative, and you need to allocate cost based on activities. So what do we mean by that? So I've seen a lot of organizations that are still using sort of a project-based funding for private cloud, which means that when they run out of capacity, the next party requesting resources will have to bear the cost of that expansion. And that sort of staircase approach to procurement is, it's going to be unpredictable, it's going to cause delays, etc. So, and that is sort of the anathema of what a cloud service should be. So the whole initiative around creating a private cloud needs to be funded and budgeted for standalone. So you can't expect your tenants to pay for the expansion sort of long term. They will do, of course, and the cost that you charge for running things in the private cloud is based on that, of course, but it can't be a straight sort of one-to-one relationship between whoever asks for new resources will have to pay for them, sort of. You need to focus on business cycles of your most significant tenants and their workloads in order to understand what drives the growth or what drives the activity of the private cloud, and how to manage the capacity underneath. As a rule of thumb, of course, the larger the cloud is, the fewer surprises. So if you have many tenants and many workloads, many applications running in the private cloud, changes in one of those will have less impact. Whereas if you have just a few applications running, or a couple of really big customers using it, each of those will have a bigger impact on the overall utilization. And in order to manage this, you need, you use a combination of linear projection and capacity modeling. Linear projection for the infrastructure level, where you don't really have a tie to the applications running or the workloads running, and then you use capacity modeling to understand the applications that are running on top. So you have a slightly different approach to how you manage this. The cloud service as such is quite similar, but for the private cloud, you also need to manage the infrastructure. So if we look at this from how the responsibility or the work of capacity management is changing, I thought this was another quite interesting aspect of this State of the Cloud report that we talked about. So this kind of view where it's sort of about the business wants central IT to be involved less and less in the provisioning and the choice of cloud brokers and the cloud providers, etc. All those are, if you compare 2018 to 19, they're all going down. So the business still wants, wants central IT to get out of or stay away from a few of those decisions, and wants to be more in control. Whereas on the top line here, we see that the responsibility for managing cost or optimizing cost is increasing, and it's quite hard to do the green one if you're not in control of the yellow one. So we're sort of tasked with this decentralization of decision power and pushing it out to the business lines and the business units, but at the same time we're expected to optimize and drive efficiency around those decisions that we are not in control of, which in itself is a hard nut to crack. So how do I then optimize the migration to cloud? Let's look at what the options are. So basically you have, you're going from an on-prem to cloud existence. The two default choices is either doing a refactoring of your application where you start from ground up and you redesign your application, or you modify your application so that it fits better into a cloud architecture, or you do the simple lift and shift where you basically take your application as is and move it over. There's actually a middle ground here that we will talk about as well that will allow you to do have the simplicity of the lift and shift, but at the same time add a bit more optimization to the picture. So what do we mean by application refactoring? So basically it's about refactoring your application into cloud native architecture. So designing it so that it uses microservices that can run in containers or can run standalone, but are smaller building blocks that can run in separate instances. That gives you this elasticity. So as you need more, you need to scale out and you need to add more power to your application, you can then spin up more microservices or add more microservices, and as activity goes down, you can retract and turn off a few instances of those microservices and turn off instances in the cloud. And by that, have this elasticity, so you don't allocate a ton of resources and then you sit on that until you turn off the application. So that is basically what cloud native means. This means that it's a sort of a upfront effort that you need to put in. So you need to do a lot of work before you can actually start to migrate. You probably spend a lot of time refactoring, rebuilding the application, and most of the effort happens on-prem. From a cost perspective, it's obviously the best way to do it. You incur most of the cost by doing the refactoring, but once you're in the cloud, you have this well-behaving application that is elastic and is only going to use the amount of the resources that it actually requires, and it's not allocating resources in an inefficient way. The downside of this, or the challenges with this, is that by doing this, you're sort of introducing multiple changes at once. You redesign and refactor your software at the same time as you're moving things to a new platform. And that's a risk in itself. So you're introducing multiple changes at once. The other one is the longer time before visible results. That shouldn't necessarily be it's not a justified complaint, but it's nevertheless, many times organizations are restless and they want to see quick results. They want to see, the initiative bearing fruit, et cetera, et cetera. So you don't necessarily get the time to do all that upfront investment in refactoring before you move things. So sometimes you're just forced to move things for the sake of it, and you end up, not being able to do the refactoring part. So the lift and shift is more the simplified approach where you take the application as is and you move it over. You look at the current configuration and try to mimic that in the cloud, and then potentially later in the life cycle of the application, you will consider doing some sort of gradual refactoring after the migration. So basically, what you do, you have this investment later. So basically the effort upfront is very low, and then you move things over to the cloud, and once you're there, you may consider doing some sort of refactoring, and that's when the effort needs to happen. From a cost perspective, it's the same. So you don't really have any initial costs. It's a smooth process from that perspective. But once you're in the cloud, the amount of resources that you're using is probably not ideal, and you're permanenting this high cost for running the application, and the ROI and the TCO of running the application in the public cloud is going to be way higher than your expectations are, at least if you listen to the vendor, the public cloud vendor, because they assume sort of that you have this elasticity and that you only pay for what you're using, or as activity goes up in an application, you're going to incur a bigger cost, but when the activity goes down, you're going to be able to release those resources. But if you haven't done that job before or upfront, that's not a given that you can do that. So you're going to have this higher cost for running the application in the cloud, and that cost keeps ticking until you've actually done that refactoring or modified the application so that it's better suited for the cloud. So lift and shift is, the challenge is obvious. The newly migrated workload will cost much more than predicted. So it's from that perspective, it's that's where probably most those stories that you hear about sticker shock or cloud shock from getting your bills from the cloud providers, that's where this originates from. So having moved application over that doesn't provide that elasticity, and that doesn't really provide cost that goes hand in hand with the amount of business activity going on. So another approach to this that we call lift, trim, and shift is very similar to a lift and shift, in the sense that you don't really invest in refactoring the application. So the normal sort of lift and shift is you look at the outside of a VM or the characteristics of a VM, or if it's a application running on physical resources, you look at that workload and try to understand how much resources are being used at different times, and what is the peak scenario, and what do we need to provision for. And then you basically find the best fit in with your provider. In this case, we used AWS as an example. So you find the best fit in terms of what instances they're providing, both from a compute and a storage perspective, and other aspects that would be of interest. But if you, instead of doing that, you spend some time to look at how that application actually uses the assigned resources or the provisioned resources. So what is the utilization? What is the cyclicality of events? So what is the business activity cycles look like? Should I use this as an on-demand or reserved instance? So do I want the elasticity to peel back on resources, or can I commit to using because I have a relatively high sustained level of activity, I may be able to save some money by getting a reserved instance instead. Do I need to incorporate some sort of growth headroom into my calculation because I happen to look at data from a certain time period that is not 100% representative of this application, and during times there is a certain growth, and I need to incorporate that into my plan as well. So all of those things mixed together will give you a probably a much smaller instance, unless you've done a really good job on-prem already, optimizing your environment. But in most cases, that is not true. I mean, most of the time there is some more optimization to be done. So we've seen customers shaving 35 to 85% by doing this. So basically reducing the amount of the size of the instances that you provision in cloud and running your VMs there without any penalty or without any risking any quality of your service, et cetera, et cetera. So there's a huge potential by doing this. And remember that this is an ongoing cost. So if you do this trim exercise during the migration, then you can, continue to save that kind of money as long as you keep the application the way it is running in the cloud. So there's a huge potential for doing that. This is an example from a QA environment. Dev and QA is typically not as optimized as a production environment, so the numbers here are probably a bit higher than they would be in a production-like environment. But in this case, if you look at what our configuration of our VMs says, we would buy instances for a total of $44,000 over a year to host this cluster of VMs. Whereas if we do an evaluation, we use the 95% percentile for our VMs and look at what they're actually using and what amount of resources are being utilized, we can cut that cost down to almost $3,000, which is a factor of at least 10 or even 15. So as I said, this is a Q&A environment where normally you provision VMs with less care and less upfront analysis, I guess. So the potential for savings here is probably bigger than it would be in a production environment. But still, you know, there's a huge potential for saving by just looking at how your workloads are actually doing. In order to do this, if you have hundreds or thousands of VMs running, you need a tool that can do this for you. To do this, you know, VM by VM, looking at historical data and try to make this analysis one by one, that's probably going to take you about the same time as it does to almost to refactor the application. So you need a tool to do this that can take this and you know, analyze hundreds of VMs in a matter of minutes and come up with a suggestion for that, and where you can set different parameters and you know what risk you want to expose yourself to in terms of how close to the actual capacity need of the VMs you want to stay, et cetera, et cetera. But this is just an example of how you can actually do this. And there's quite a lot of money to be saved by doing this. So what is then the best migration strategy? To summarize it, you know, the ones that considers the characteristics of each workload. There is no simple way of just saying that, you know, you should always refactor everything, or you should always lift and shift and then refactor after that, or you should, by doing lift, trim, and shift, you never have to worry about anything else, etc. So it's not that simple. You basically need to look at each workload and try to determine what the characteristics of that workload is, or that VM is. So from an architectural fit, is it a monolith application? Is this a service-oriented application already before we do the migration? What is the current cost of ownership? Are we concerned about the high cost of ownership for that specific workload, or is it, you know, low and not something that we are overly upset about? What is the business process characteristics? Is it a fairly static application, having a sustained load and predictable load, or is it a dynamic application that has certain peaks or sudden peaks that are a bit unpredictable, where we need to burst out and use more resources at times, whereas at other times it's fairly low on resources? And what is the demand profile look like? Is it a stable application, or is it, you know, highly variable? Is it subject to end customers or, you know, other upstream, downstream applications that are causing the demand profile to look very different at times? So looking at all those different aspects and taking them into consideration, you have to decide workload by workload, what is the best migration strategy? The simple answer may be that it shouldn't be in the cloud. It should be on-prem, because it doesn't have the characteristics, or it doesn't have any potential to run better or cheaper in the cloud. Or we could look at refactoring the workload, or we could look at the lift, trim, and shift approach. So the best migration strategy simply needs to be decided based on the characteristics of that workload. So how do you then optimize ongoing cost? Once you're over in the cloud and you have everything up and running, how do you optimize the cost ongoing? There's a number of simple recommendations that I will go through. The first one is to define what are the allowed instance types and sizes. So even though a public cloud provider may offer a ton of different types of instances, you should try to identify a handful of those that are the typical ones that we would use for different types of workloads. And then you need to enforce those by policies. This will also protect you from automation mistakes, because in public cloud, most of the time, the provisioning of new resources and etc. is automated through scripting or through frameworks that the public cloud provider offers. And if you have these limitations of allowed instances, etc., you can avoid mistakes that happens, you know, by the way you've designed your automation. For this to be effective, of course, you also need to combine this with limitations in number of instances that a user can create, of course, otherwise they can easily work around this. You need to enforce tagging, so you need to tag resources with business unit, service, application, owner, etc. If you don't do that, it's going to be really, really difficult to follow up on cost, and you can't track and report on consumption and cost by peer, whatever that peer is, if it's a business unit or if it's a specific application or service, etc. But it's absolutely mandatory to have a tagging standard for resources that are being created, and that can also be enforced by policies. And you know, if you lose control over that, you very soon find that it's going to be extremely difficult to keep track of what's running in public cloud and how much is being consumed by different types of workloads and different types of applications. You have to have these ongoing right-sizing efforts. We talked about this before. So proactivity used to be the sort of the axiom for how you did capacity management. But since you lose some of the control over the provisioning, and a lot of the provisioning is happening by automation, you have this infrastructure as code approach. You need to do retrospective analysis where you try to identify dormant resources or archaic data stores that aren't being used anymore and reclaim those or turn them off. So you have to do this constantly. You need to do it over and over again. You need to do it on a daily or weekly basis because patterns changes, the activity of application changes, whatever assumptions were made when you initially sized a resource in the cloud may no longer be true. And in that case, even though it's not only for a month or a few weeks, and then, you know, it's going to happen again, you need to do this over and over again. You need to ruthlessly try to right size your environment because that has a direct impact on the bill that you get at the end of the month. You need to work with reserved instances. There's a number of different discount ranges that you can get depending on how long you commit for those reserved instances. So you can commit for a 1 or 3 year period normally. How you deal with the payment. So if you do no upfront payment, or if you do a partial upfront payment, or if you do everything upfront. The more upfront you do, the more discount you will get, of course. And then you can have different classes of reserved instances, standard ones and the convertible. Convertible means that you can basically reuse that reserved instance for another purpose, and you can change the characteristics of that reserved instance, whereas a standard reserved instance stays the same throughout the lifetime of that. So all those things needs to be considered and taken into the analysis. So some best practices around that that we've seen with customers we worked with. The first one is, you know, moderate gains are if you're using less than an instance less than 65% of the time, there's probably no reason to go for a reserved instance because in that case, the discount that you get is going to be over, or it's going to be it's not going to make up for the amount of resources that you're wasting by not using it all the time. You should never buy reserved instances for a specific instance or sign up for RI for a specific instance. It should always be on an instance class. Otherwise, it's really difficult to manage. And if you have a lot of instances running in the cloud, it's going to be really, really difficult to manage that. And also, you need to take a sort of just-in-time approach to this. We've seen some companies that are doing yearly sort of purchases of reserved instances, but in a dynamic environment where things tend to change more frequently, it doesn't make sense to do that. It's much better to have more frequent times when you evaluate your situation and decide whether there's need for more reserved instances or whether you should release some of your reserved instances that are running out, etc. This needs to happen closer to the actual activity, not at the beginning of a year. It's similar to, you know, running things on-prem. If you were to every time at the beginning of a budget year, you buy everything that you expect to be using during that year, and then you put them on a shelf, and then you start using them over in October. It doesn't make sense. Doesn't make sense to have reserved instances on a yearly basis either. It's better to do it closer to the actual event. You need to assign expiration dates to everything, especially in dev test environments. You should always have a expiration date on everything. You can't allow it to happen without expiration. And then you have authorized users who can extend those expiration times when they need to, but an instance without expiration is a potential liability, or it's going to cause, you know, it's a potential that it will run forever and you won't use it, but it's never going to be turned off. So always assign expiration dates. It creates some extra work, but as long as you have a system around it, you know, the impact of it can be managed. Shutdown workloads after hours sounds like a simple recommendation, but it's not being used that much actually. It's very easy to automate. If you have operation that runs for a specific, unless it's 24/7, there's times when you don't need to have certain instances up and running, and they're going to cost even though they're not doing much. So turning them off is a good idea, and this could save you, especially in dev and QA environments where you normally have a shorter window of activity, maybe like 8 hours in 24 or something like that. Turning those off during inactive hours can save you up to 70%. So especially for dev and QA environments, there's a huge potential for saving money by shutting down workloads after hours. And then the next one is enterprise discounts. So if you can commit to a spend over multiple years, you can get discounts of, we've seen 10% and upwards with bigger customers we've been working with the big cloud providers, public cloud providers. But then you need to commit to this cost. So you need to understand, you know, what are your expectations. So you need to have an understanding of what are your business plans, and then what is your cloud roadmap. So how much of your applications or workloads are going to be moved over to public cloud, and what are the growth plans for those applications, etc. And all that needs to be taken into consideration because you're committing to a certain spend and whether you're actually going to use it or not. So it's tempting to get this discount, but with that comes an obligation, of course. So in order to do this, in order to make use of this, I would recommend that you have a relatively mature approach to how you use cloud. So if you look at again, back to this right scale state of the cloud report, there's 4 different levels of maturity in cloud. So watchers, beginners, intermediate, and advanced. I would argue that you should at least be in the intermediate stage and before you start to seriously consider committing to a long-term spend in cloud, because if you're at the very early stages, it's guessworks and it's a bit risky to sort of commit to that kind of cost. So, but if you're a relatively mature user of cloud services, you know, committing to a long-term spend can give you a relatively good discount. Another aspect that also needs to be considered for this ongoing optimization is the cost allocation. So how do I allocate costs to my organization? If we look at the traditional IT cost management maturity, first step is to just measure basically, or metering, so you can tell how much is being used by different parties or different departments or business units or internal customers or whatever you call them. The next step is you multiply that usage with the running costs, so you keep track of how much cost that is involved in running those different types of workloads, and you show this back, or you do a show back to the consumers to try to make them aware of how much resources they are using and what the cost is that they are incurring. And then ultimately you charged back. So you invoice them for what they're actually using, and that is sort of the ultimate level of IT cost management maturity. That used to be the case for on-prem. In the cloud, since you get everything itemized and you get everything presented back, at least if you've done your tagging, etc., of your resources, you will get this information. You know that what used to be a challenge in traditional on-prem environments where you had to put metering in place and you have to sort out every aspect of cost for your infrastructure, etc., is now much easier. In public cloud, this is the bill that you're getting basically. So if you've done your tagging, you're going to get a bill at the end of the month that shows you exactly how much each tenant or each application has been using. So you should charge back. Just absorbing the cost for the whole enterprise public cloud usage in one place is absolutely the wrong way to go. So the reasons for doing this, I mean, obviously transparency. So you need to show to the organization how much resources that have been used, but also, the fully burdened cost. So also the, what is the cost for the governance that we need to add to the public cloud service, because it's not just the cost of the cloud services as such, it's also the governance of it and the security around it, etc., that we need as a company needs to provide on top. It's used to influence the rest. You can drive different type of behavior. So if you want to reduce the consumption or you want to incentivize move of customers off a legacy architecture or an application, etc., you can price them differently. So it's a good way of controlling behavior of your internal customers, but it's also a way for consistency. So if you let every business unit carry their own cost for IT, it's much easier to do a fair evaluation and profitability analysis of those on a business level. So you should really look at doing some sort of chargeback, full cost recovery for your cloud services. So that concludes the part of the ongoing cost control. So in summary, how do we keep costs down? So as we concluded, the first thing we concluded, capacity management is still relevant in the cloud. It changes somewhat. You need to focus on slightly different things. You need to treat things in a slightly different way. You need to relearn to do things in a slightly different way, but it's still very much needed. There's no such thing as an infinite cloud where you can just push your workloads and they will, you can forget about any type of capacity issues in the future. Migrating workloads to public cloud takes careful consideration. So the choices that you make will have a lasting cost impact. So whether you refactor your application and take the investment up front, or if you do the lift and shift, which is more of the from the backloaded kind of approach where you move quickly, but then you have a higher cost as you run it, or you can do the lift, trim, and shift where you take the easy way of moving applications the way they are, but you take a hard look at how they're actually using resources and try to optimize the allocated resources. And then for the ongoing cost control, you need to do a number of different tactical and strategic activities. You need to do ongoing right sizing and reclamation. As we said, you lose control of some of the provisioning, so all the more reason to constantly right size and look for possibility to reclaim resources. You need to have look at service charge discounts in return for future commitments. So you need to have a long-term roadmap and a plan for what you're going to put in the cloud. And once you have that, you can confidently commit to a certain spend, and by that you can get a discount from your cloud service provider. And then you should always try to recover the cost for the cloud service based on the actual consumption. There's so many different reasons to do that. It's going to make your internal customers more careful about what kind of resources they ask for. You can do more fair evaluation of different applications and different business units inside your company, et cetera, et cetera. So there's a million reasons to do cost recovery based on actual consumption for your cloud services. So that is, in conclusion, these were the sort of recommendations that we've come up with over the last 5 years that we've been working with a lot of customers, starting or not finishing, but are well into their journey into, putting applications and workloads in public cloud as opposed to on-prem. So with that, thank you for your attention. And if there's any questions, I think we have a couple of minutes at least, so we can maybe answer to a couple of those.
Yes, Per, we did have quite a few questions come through, actually. So the first one is, are you suggesting we should stop being proactive in the cloud as capacity managers?
No, absolutely not stop at all. We need to pay more attention to retrospective activities like right sizing and reclamation, because we will have less control over how resources are provisioned. We still should do proactive procedures, but we need to be careful because we don't want to interfere with the agility of infrastructure as a service, in public cloud. The whole concept of public cloud is it's supposed to be agile, it's supposed to be quick, it's supposed to be simple to provision new resources, and we need to keep it that way. And with that, we give away a bit of the control, and that means that we need to be more focused on the reactive and more frequent, try to do those reactive right sizing activities. But of course, any type of proactivity that works with the operational model of public cloud or cloud altogether is absolutely, we should still do.
Great. Okay, so the next one is, based on your experience, which is the most common method of cloud migration?
Well, so even though many organizations actually do take time to refactor some of their existing workloads before migrating to cloud, I think the lift and shift is by far the most common. That's what we see the most. At least in terms of number of workloads being moved, maybe not the most critical ones or the most important ones are treated that way, but in actual numbers, I think lift and shift is the biggest one. I think most organizations probably understand that they could benefit from a bit of trimming during the migration, but they simply don't have the tools or the bandwidth to do it or the confidence to do that. So rather than risking anything, they sort of bring that inefficiency or over provisioning with them over to the cloud. But it's important to understand that if you do that, the result is not the end state. So whatever you put out there, you have to probably do a bit more in order to long-term have a sustainable sort of TCO in the cloud. Okay.
Now, we have quite a few other questions, but one of them that came in that I wanted to address if people start leaving is, how do we contact HelpSystems? And you will receive a follow-up email with the recording from this webinar. And then I'm not sure what additional information that you'll be sending, Per, if you know that off the top of your head, but you will definitely receive a follow-up email that will have contact information.
Absolutely. Yeah, definitely.
Okay. Do you want to continue with the questions, or would you like, because we have quite a few left, would you want to answer a few more, or would you like to address?
Sure, we can do that as long as people are able to stay on. Absolutely.
Okay. The next one is, fair cost allocation more important for the cloud compared to traditional IT?
So that is the subject we sort of touched on here. I can't really say it's more important, but what I do know is that nothing beats proportional charge out when it comes to controlling or trying to sort of curbing the appetite to request resources, and it's always important. In traditional IT, it was a challenge to make this happen because you had to put monitoring in place. You had to have the cost structures, an understanding of how cost was incurred in your data center, and all of that was a multi-year journey and a long process. And to implement that was quite a big project. In public cloud, you get all that for free. I mean, the bill that you get at the end of the month, that's basically your charge out bill. This is what different people have been using. And, since you have that, it's just there in front of you. It's stupid not to charge out the cost to the different business units. I think most companies do that, but we've seen examples of where public cloud is treated as this, cost center, so the corporation or the enterprise absorbs all the cost for public cloud from the different business units. And that is really, poor management of your cost, because if you do that, you're never going to make your different tenants aware of how much you're using, and they're not going to be motivated or incentivized to do something about it. So absolutely, I think it's more important because it's so simple now to do.
And the next one we had come in is, how high should you set the bar when it comes to predicting cloud bills?
Yeah, that's a good question. So it's important to have realistic expectations when it comes to how much you can predict. The complexity, both in terms of accurately forecasting demand, but also in exactly predict the impacts of your different pricing policies that you have. We talked about this reserved instances, and those reservations can move around, and they are not necessarily applicable to a different region or a different data center with that provider, etc. So there's a ton of complexity involved in this as well. So to do an accurate prediction based on that, there's so many different things in play here. It's hard to do that, but it's more about making predictions that are in the same range as the bill when it actually eventually arrives. So beyond the next bill, you need to make sure that you're on track to stay within budget constraints from a quarterly or annual perspective, but more, making sure that you're tracking towards an acceptable cost at the end of the year or at the end of the quarter, rather than down to cents or pennies, because that's going to be pretty difficult or impossible to predict. But that's another area where we've really seen a lot of the customers we work with have matured a bit, and they are much better. I mean, it takes you need to get a few bills before you can actually start to be confident enough to forecast. But once you start to get things up and running, and you have a steady workload running in the cloud, we've seen a lot of the organizations we're working with, they've become much better at doing that kind of prediction. That doesn't necessarily mean that prediction you shouldn't confuse prediction with cloud with cost optimization. May still be a lot of optimization to do in terms of cutting cost, but at least you won't get surprised at the end of the month. So you need to keep those two things separate, I guess.
We had another one come in that addresses cloud versus on-premise. So is cloud spend a challenge because cloud cost is readily available and visible compared to on-premise infrastructure cost?
Yeah, absolutely. I think that's a big part of this cloud shock stories that you've seen or read about, is that a lot of the cost in a data center and on-prem is hidden, and it's not really in your face in the same way. There's a lot of sunken cost that has already been absorbed by the organization, and you don't necessarily, even though most of the capital expenditure or capital investments that you've done has a depreciation over a number of years, it's still not as apparent, and it's not a bill that you have to pay every month. So absolutely, the OPEX cost structure is a bit more visible, I guess, than the traditional sort of capital investments with depreciation. Yeah, absolutely.
And is an organization's cloud spend normally a new additional cost, or does it replace a current cost? And then what are you seeing with your customers?
I think over time it will be replacing existing cost. Again, back to the capital investment that has a lifetime of a certain number of years, etc. It's not like just because you're migrating a workload over the cloud, you can't recover all the costs that you had. You can probably recover some of the electricity and carrying and feeding of those systems, etc., because someone else is doing that for you. But the capital investment is still there. The size of the data center is still there. The amount of cooling and staffing that goes into running that data center, it's not going to change overnight. So absolutely, I think migrating workloads over to the cloud will, short term, it will probably, you will double a few of the costs, but longer term, you will be able to recover that. And hopefully you'll get to a level that is lower than where you started. So it's not, they don't go hand in hand sort of, or follow each other very closely necessarily in the beginning, at least.
And we have one more question. How do containerized environments that share resources benefit or challenge capacity cost management?
Yeah, that's a good question. So, of course, it's challenging in the sense that if you're mixing multiple workloads or application belonging to different entities, like different business units or different business services, etc., on the same infrastructure. So you have basically a shared resources, which is the most economical way, I guess, of hosting containerized workloads is running large clusters where you manage those applications by orchestration software, but eventually they will sit on the same infrastructure and they will use the same resources. And in those cases, it becomes challenging. If you do that in the public cloud, you can still use tagging and you will still get very good traceability of each individual container and how much it's using. If those microservices and containers that are running those microservices are shared by multiple different applications, you'll have to come up with some sort of simplified model where you just assign a percentage number and you do some sort of fair estimate of how much they are using it. It's not a science, and it will never be. And I think setting the bar too high in terms of traceability is probably not worth the effort. If you can't track it by tagging, I think a simplified model where you assign a certain percentage is probably the best way to do it. Anyway, anything beyond that is maybe a intricate matter, and it's a interesting challenge, but it's not necessarily beneficial to the business, or it doesn't drive behavior in the good of the business, sort of. Okay.
Well, thank you again. That was our last question. So I'd like to thank Per Bauer and HelpSystems for this webinar. And again, if you guys have any more questions, you will be receiving information from HelpSystems, so you can reach out. And have a great afternoon, everyone.
Okay, thank you very much for your attention.
Bye.